Immersive augmented reality systems enable users to seamlessly overlay virtual content onto their physical environments. Co-located collaborative AR has enabled shared entertainment AR experiences, collaborative content authoring, and etc. However, enabling mixed reality collaboration for remote users is limited by misalignment between distinct physical environments, forcing users to rely heavily on virtual content or essentially identical physical spaces. Meanwhile, lacking the access to remote physical environments, existing remote collaborative systems lean heavily towards either the physical or virtual space, rather than harnessing the potential of both. We present SurfSpace, a general-purpose symmetric remote collaborative system with head-mounted mixed reality displays. Our system creates a physical virtual workspace between two remote users anchored on a physical plane in each environment, while assuming minimal similarity between the users' respective physical environments. Our system has a lightweight hardware setup and only requires a pair of Microsoft HoloLens 2. The user set up the system and establish spatial consistency by defining the virtual portals, from which they can bring physical and virtual objects into the collaboration. The first user uses a pointing gesture to select the corners of their local portal. This portal then becomes visible as a movable rectangle in the second user's view. The second user uses a pointing gesture to play the first user's portal in their environment, then uses pointing gestures to define their own portal. The system establishes spatial consistency by synchronizing the relative transformation between each user's portals. Once the virtual portals are set, the system initializes an audio-visual connection and renders each other's virtual avatars. Each portal represents a two-dimensional slice of the physical environment a user wants to share. ShareSpace achieves this by streaming the video of shared physical surface captured from the HoloLens video camera. We had stabilized the video with holographic projection and avoid distortion and parallax errors caused by user movements. By overlapping the portals, users create a merged shared physical surface. By default, the system streams background subtracted videos, allowing users to share physical objects as overlaid images. With physical object sharing, our system can enable remote physical games such as checkers. For example, one user can share a checkerboard with the system, and two users both join the game with a set of their own checker pieces. With the background subtracted, the users only see overlaid images of each other's checker pieces. Using a head-mounted headset allows users to conveniently set up shared surfaces anywhere in their environment. For example, one user can set up on a whiteboard, while the other user can set up on a desk. In certain scenarios, a user might want to share their entire space for the other user to annotate. In this case, they can choose to turn off background subtraction on one side. Here, a user shares a finding difference picture on their screen for the other user to play with. With background subtraction, one user's hand-drawn annotation on the whiteboard can seamlessly overlay on the other user's physical screen. Users can also replicate physical objects into the virtual space for both users to interact with. The virtual replicas are shared between the users. Here, a user creates and extrudes an object and hands it to the other user. Our system allows freehand manipulation with the virtual replicas, including extrusion, shear, move, and scaling. Our system supports ad hoc creation of virtual replicas simultaneously for multiple planar objects with arbitrary shapes. The creation of virtual replicas can allow a remote instructor to demonstrate without having the physical assets. Here we show the remote instructor demonstrating how to construct a fish shape out of tangram pieces. Users can also use ShareSpace as a remote collaborative AR content authoring tool. Here we demonstrate two users constructing a brick castle by creating virtual objects from shapes cut from paper. Finally, our system allows users to create objects with physics. With such objects, remote users can play room-scale recreational games. Here we show two remote players playing mini bowling. One user can use a set of circles as bowling pin generators, while the other user can create a virtual bowling ball from another circle. We conducted a user study evaluating 4 application scenarios of our system: hand-drawn annotation on a remotely shared surface, remote instruction with tangram puzzles, mini bowling alley, and collaborative prototyping of a brick castle. Users fill out a system usability scale to evaluate the system's overall usability and reflected on their experience with the system in a semi-structured user interview. We believe that shared space blurs the boundary between remote spaces for remote communication and provides insights for bringing the remote collaborative experience closer to natural in person interaction. For more details, please refer to our paper.